Hi everyone, and welcome back to my virtual classroom. For those that are new to my class, please don't forget to click that subscribe button and hit that notification bell for your attendance today. And for our science discovery today, we will be talking about gas laws. Yes, you heard me right. It's about gas laws. So before anything else, before we go and jump into our whiteboard and learn something about gas laws, as always, as Teacher Maria would say, please do live your life to the fullest, learn something new every day, and love one another as how our God loves us. Alright, so let's get started.
Gas laws. For this episode, we will be talking only about the 3 gas laws. But before anything else, let's first do a quick recap on the properties of gases. We all know that gases has no definite shape, no definite volume, and they are compressible. And they also have the kinetic molecular theory. Therefore, in gas laws, it's important to understand gas pressure. When we say gas pressure, pressure is the force exerted on a container's wall by particles in a gas. The units that we use is kPa or kilopascal, atm or your atmospheric pressure, torr or torricelli, and mmHg or your millimeter mercury. The gas laws are being used at STP, which means standard temperature and pressure. When we talked about standard temperature, that means that we are to use Kelvin. How do we convert Celsius to Kelvin? In converting Celsius, we only need to add 273 so that we will get Kelvin. So therefore, if we have 0 degrees Celsius plus 273, then we will get 273 Kelvin. In terms of pressure, 101.3 kilopascal is equivalent to 1 atm or equal to 760 torr or mmHg. This is important if you have different units or different givens in your pressure. What are the factors that affect pressure? The first one is the amount of gas or the number of moles inside your container. The increase of amount will also increase the pressure, and vice versa. For example, the bicycle tires and the car tires. That means the amount of gas inside. You should know the amount of it so that it won't explode or pop out. That means that as the amount increases, the pressure will also increase. The next factor that affects pressure is temperature. The increase in temperature will also increase the pressure and vice versa. For example, your tires deflate in winter. The next factor that affects pressure is volume. The decreasing volume will increase pressure. And when it is increasing volume, it will decrease pressure. For example, as you press down a balloon and it pops, that means that you increase the pressure, therefore the volume decreases. The first law that we will be talking is Boyle's law. Boyle's law states that as pressure and volume having an inverse relationship in constant temperature. That means if volume increases, pressure decreases by the same factor. So the formula for Boyle's law would be P1 times V1, or your initial pressure and volume, is equal to P2 times V2, or your final volume. Let's take, for example, a gas with a volume of 4 liters at a pressure of 205 kPa is allowed to expand to a volume of 12 liters. What is the pressure in the container if the temperature remains constant? The first step to do for us to be able to solve is to identify the given. First given is volume 1, which is 4 liters, pressure 1, which is 205 kPa, volume 2, which is 12 liters, and pressure 2, which is unknown. Using the formula, P1 V1 equals P2 V2. Since we're looking for P2, we will transfer V2 to the other side, and that will be divided. So P2 is equal to P1 V1 over V2. Then we substitute the given. P1 is 205 kPa. V1 is 4 liters. V2 is 12 liters. Liters and liters cancels out. So 205 times 4 divided by 12 would be our pressure, which is 68.3 kPa. The next law is Charles' law. It states that volume and temperature have direct relationship if pressure is held constant. If temperature Kelvin increase, volume also increase by the same factor. That means if we put it in formula form, V1 over T1, or your initial volume temperature, is equal to V2 over T2, or your final volume temperature. Let's take, for example, a gas occupies 900 ml at a temperature of 27 degrees Celsius. What is the volume at 132 degrees Celsius? So the first step is to identify the given. V1, which is 900 ml. T1 is 27 degrees Celsius. And since that is in Celsius, we have to convert it to Kelvin. So plus 273, that will give us 300 Kelvin. V2 is unknown. We're looking for V2. And T2 is 132 degrees Celsius. So plus 273, that will be 405 Kelvin. Using the formula, V1 over T1 equals V2 over T2. Cross multiplying it, V1 times T2 is equal to V2 times T1. Since we're looking for V2, we will rearrange this, making V2 as our subject, V1 and pressure 2, which is 90 pounds per inch square. Using the formula, P1 over T1 equals P2 over T2. Rearranging that, we have P1 times T2 equals P2 times T1. Since we need T2, we will move P1 to the other side of the equation. Therefore, T2 is equal to P2 times T1 over P1. So we have T2 equals P2 is 90 times T1 is 300 divided by P1, which is 30. 90 times 300 divided by 30 would be our T2, which is 900 Kelvin.